In this lecture, I want to continue our discussion of 4.4 and discuss the second derivative test. So the overall title of the section is shape of a graph, but we're going to use what we know about the shape of the graph in order to determine what the nature of a critical point is. In other words, is that critical point a maximum or a minimum? So remember from the last lecture, if the second derivative is positive, we're concave up, and if the second derivative is negative, we're concave down. So suppose that C, some x value, x equals C, is a critical point. All right, so remember, a critical point is where, so that means that either f prime of C equals 0 or f prime of C does not exist. All right, but we know that the maximum or minimum of a function will happen at a critical point. So we want to look at how could we use this idea of, remember, this is the shape of f. We can get that from f double prime. We can use this shape in order to determine if our critical point is a max or a min. And it's really pretty simple. If you look at this, if you know, so clearly if you look at this, the critical point is going to be down here, right? This is where it's going to be 0 or up here, all right? So if we put in C into the second derivative and determine what the sign is, in other words, if the second derivative evaluated at C is positive, then we have to have this situation here, right? It's going to be concave up right at C, if that's C right there. So if it's concave up, then we know that what we have is a minimum, because our critical point happens at kind of the bottom of this. Whereas if the second derivative is negative, then we have this situation going on. All right, and again, it's the second derivative evaluated at whatever our critical point is. So in this case, we would have a maximum, right? Because our critical point is at the top of this concave down shape. So what I would like to do is just go through two examples of how to use this. So here's the first one. Suppose we have this function x e to the negative x. All right, so here's a good review on derivatives. So we take the first derivative, we need to use the product rule here, right? So the derivative of the first is 1 times the second is e to the negative x, plus x times the derivative of e to the negative x. All right, well, this is a case of e to the f of x, right? So the derivative is f prime e to the f of x. In this case, f of x is just negative x. So the derivative of negative x is negative 1 times e to the negative x. All right, we can clean this up a little bit by rewriting it e to the negative x. Instead of plus and negative, we say minus x e to the negative x, and we can clean it up a little bit more by factoring out an e to the negative x, so I end up with 1 minus x, right? If I expand this back out, e to the negative x times 1 gives me e to the negative x, and then minus x gives me this, all right? And in order to find the critical points, I need to set this equal to 0 and solve. And also we need to look at where it could be undefined. Well, the domain of e to the x, or e to the negative x, is all real numbers, and this is just a linear function, right? We can think of it as negative x minus or plus 1. So there's not going to be any place where the derivative is undefined. The other thing we need to notice is, so the product of these two things is 0. So that would mean that either e to the negative x equals 0 or 1 minus x equals 0. Well, if we remember what the graph of this looks like, all right? So I'll just kind of do a little graph over here. All right, it looks like this, right? It's never equal to 0. There's nothing we can put in for x. We can't raise e to some power and make it negative that will make this equal to 0. So this will never happen. All right. So the only way this product equals 0 is if this equals 0, and that happens when x equals 1. So there is our critical point. All right. Now to use the second derivative test, believe it or not, we actually need the second derivative. So let's start with this and find the second derivative. All right. So again, I'm going to use the product rule. So I have the derivative of e to the negative x, which is negative e to the negative x, times the second function, which is just 1 minus x, plus the first function, which is e to the negative x, times the derivative of the second. And so the derivative of 1 is 0, the derivative of x is 1, so I'm just left with a negative 1 there. All right, so let's clean this up a little bit. I'm going to bring this negative in here, so if I distribute it to the 1, that becomes negative 1, that becomes positive x, so I have e to the negative x times x minus 1, and that's just going to be minus e to the negative x. One more time, I'm going to pull this e to the negative x out. I'm going to kind of factor it out of this term and out of here. So here I'll be just left with a 1, so I'm left with kind of an x minus 1 minus 1, right? Because I can multiply this back to get that term and multiply that back to get this term. And then in here, I can simplify. I have e to the negative x times x minus 2. That's my second derivative. Well, what we want to find out is if this critical point is a maximum or a minimum. So remember, coming back up here, we can put this critical point into our second derivative, and if our second derivative is positive, we have this situation going on, it's a minimum. If our second derivative is negative, then we have this situation going on, and it's a maximum. So let's put 1 in here. What do we get? So f double prime of 1 is e to the negative 1 times 1 minus 2. All right. Now, again, here's the graph of e to the negative x. It's never negative. It's never 0 or negative. It's always positive. All right, so that's always positive. And 1 minus 2, so that's positive. That's negative, so their product is negative. All right, so the second derivative evaluated at 1 is negative. That means I have this situation going on right here, and that means that my critical point is a maximum. Okay. So that's one example, and then I want to continue the example from the last lecture that we looked at. All right, just to remind you, we were looking at this function here. All right, so this is one that I want to take a look at because there's something interesting happens where the second derivative test is inconclusive, and I think it's important to see an example of that. So let's real quick kind of repeat. So if we have f of x equals x to the 5th minus 5x to the 4th, f prime is 5x to the 4th minus 20x cubed. And we need to find, last time we didn't find the critical points. Here we need to because we want to know if those critical points are a max or a min. So we set that equal to 0. Let's pull out, I don't know, 5x cubed, right? That'll leave me with an x minus 4, all right, equal to 0, so that means that either 5x cubed equals 0 or x minus 4 equals 0. The only thing that would make that true is for x to be 0, and here I have that x would equal 4. So these are our critical points. Okay, now, if I want to use the second derivative test to test these critical points, I want to put them into the second derivative to determine if the second derivative is positive or negative at these points. I need to find the second derivative, which again we did in the last lecture, but it's easy to do. I'll start with this one so I don't have to use the product rule rather than the factored form. So I have 20x cubed minus 60x squared, all right? And it might be easiest to factor here in order to test these because all we care about is if it's positive or negative, right? So if I pull out a 20x squared, I'm left with x minus 3. Okay, so here is our second derivative. I need to check f double prime of 0. So this is the second derivative test now, right? I'm going to check this each of these critical points. I'm going to put them into the second derivative. If the second derivative is positive, then it's concave up, and I have a minimum. If it's negative, then it's concave down, and I have a maximum. All right. Well, f double prime of 0 is 0. That is the inconclusive case. All right. If the second derivative is also 0, we don't know. All right. We may or may not have an inflection point, but that's not the point. The point here is that we don't know if 0 is a max or a min of this function because the second derivative is not positive or negative. All right. So that one's inconclusive. We can still put in 4. All right, and we get, if we put in 4 here, well, that's going to be positive times 4 minus 3, which is positive, and that's positive. So what I have is it's concave up at that point. That means I have, at this point here, for that critical point, it's a minimum. All right, So what are we going to do about this? All right, well, we have some other tools, right? We have the first derivative test that we could try. So this is a good review for the first derivative test. Let's go over here, and we already know about force, so we don't need to worry about force so much, right? We know that the first derivative is 0 at 0. We need to see what the sign of the first derivative is on either side of 0. So let's come back up to this right here, and let's try -1, right? So if I have 5 times -1 cubed times -1 minus 4, well, this piece right here, that's going to be negative, right? Because -1 cubed is -1 times 5, so that's negative. And clearly here, -1 minus 4 is also negative. So the product of two negatives is a positive. So the first derivative is positive here. That means our function is increasing, right? The function is increasing here. And then let's try on the other side, we could put in 1 to our first derivative here, okay? So if I put in 1, I have 5 times 1 cubed times 1 minus 4. So 1 cubed is 1 times 5, so this piece right here is positive. And over here, 1 minus 4 is negative, so the product is negative, and it's negative over here. So what I have is, it's increasing, it's 0, and then it's decreasing. So clearly at x equals 0, I have a max. All right, so this will happen sometimes where your second derivative is 0. We could actually, while we're at it, let's just check to see if we have an inflection point going on here or what. So if I look at the second derivative, so 0, here's the second derivative. I put in something less than 0. So let's say -1. Well, -1 squared is positive, so that's, well, I'll do it down here. So f double prime of -1. Like I said, -1 squared is positive times 20. That's positive. -1 minus 3, that's negative. So I'm going to be concave. It's negative over here. I'm going to be concave down. Do we have a change of concavity on the other side? Let's try +1. All right. Well, squaring 1. So I've got that will be positive, right? Squaring 1 is 1 times 20. That gives me a positive, and 1 minus 3 is negative. So that's negative. So it's not an inflection point. We actually, this is consistent, right, with what we see up here, that all along this interval here, it's concave down. But right at 0, we didn't know what was going on. It wasn't positive or negative, right? So so the point is that sometimes the second derivative can be inconclusive, and in those cases we want to look for other ways to test our critical points. So we've got a couple tools available to us. We can use the first derivative test or the second derivative test. You should be familiar with both of them, and you should be able to apply both of them.